All right, in this video we're going to be talking about a few questions that are found from Release Star questions. And these are the TEKs that we're going to be going over. 6.3a, recognize that dividing by a rational number and multiplying by its reciprocal result in equivalent values. 6.3b, determine which with and without computation whether a quantity is going to increase or decrease when multiplied by a fraction, including values greater than or less than 1. And 6.3c, represent integer operations with concrete models and connect the actions with the models to standardized algorithms. All right, so the first question is 6.3a. This is from the 2016 test. A carpenter wants to cut a board that is 5/6 feet long into pieces that are 5/16 feet long. The carpenter will use the expression shown to calculate the number of pieces that can be cut from the board. So as you can see, anytime we have a division problem, the first thing you have to ask is what is being divided up, and it's the board. And how long is the board? It's 5/6 feet, so it's going to go first. Whatever you're dividing, if you're writing the division horizontally as such, it's going to go first. Okay. So we're dividing 5/6 by 5/16. Which expression can be used to calculate the number of pieces that can be cut from the board? Now, as you look at your answer choices, they're not asking us to solve this problem. So what are they asking us to do? They're asking us to find an equivalent expression to 5/6 divided by 5/16. An equivalent expression, well, these are equivalent fractions. They are not the same. 1/2 is not the same thing as 4/8. If I had a pizza and I divided it into 2 slices and I had 1 out of 2, or if I had a pizza, do a different color, and I have 4 slices out of 8. Now, I'm sure you're saying, but Mr. Hewlett, you still have half of a pizza in either one. While that's true, it's divided up differently. Having one really big slice of pizza is different than having 4 smaller pizzas. Sure, you still can eat the same amount of pizza, but it just looks different. They are equivalent, they are not equal. So, as we look at this, we have to ask, how do we divide fractions? To divide fractions, I'm going to write this down, so we have 5/6 divided by 5/16. When we divide fractions, what we need to keep in mind is we need to turn our division problem into multiplication. We should know how to multiply fractions. If I had 1/2 times 1/2, I multiply my numerators together, I multiply my denominators together, and then I'm done. That's all you have to do. Numerator to numerator, denominator to denominator, and you call it real. Of course, you simplify if needed. So, but that's if it's already written as a multiplication. This isn't. So what do we do for division? We leave the first fraction alone. We change the division to multiplication. If we're changing it, obviously we have to do something to the problem, because you can't just turn it from division to multiplication. So the second fraction, we're going to find the reciprocal. And what does it mean? And as you can see in the TEK, it says reciprocal. What does it mean to find the reciprocal? The reciprocal means ultimately just to flip. And so, as you look at your answer choices, our answer choice would be F, because we kept the first fraction the same. We turned the division into multiplication, and then we found the reciprocal for 5/16, which is 16 over 5. And that's our answer. They didn't ask us to solve it, but if they did, we would just multiply. 5 times 16 is 80. 5 times 6 is 30. Cancel that. That's 8/3. Divide 8 by 3. 3 will go into 8. 2 times with 2 as a remainder, and your denominator stays the same. So if we did solve it, we would get 2 2/3. Now really fast, now it's not on the problem, but what if I had, what's the reciprocal of 2 over 1? Well, you just flip it, it's 1 over 2. Pretty easy. Again, the denominator becomes the numerator becomes the denominator. Well, what if I had 2 and 1/2? What if I needed to find the reciprocal of 2 1/2? Before I find the reciprocal of a mixed number, I need to turn it into an improper fraction. In doing that, I usually call it MAD, multiply, add, denominator stays the same. 2 times 2 is 4, plus 1 is 5, and denominator stays the same. And then once I can find the reciprocal, which would be 2 over 5. So the reciprocal of 2 1/2 would be 2 over 5. And that's how you find the reciprocal of a number. All right, let's look at the next problem. Which expression is equivalent to 8/9 divided by 3/4? Again, we're dealing with a fraction problem where we're dividing. As we know from the previous problem, when we have a fraction problem, when we're dividing, we have to keep it, we have to change it, we have to flip it, and flip it means find the reciprocal. So, as you can see from the answer choices, they're not asking us to solve it, they're just how would you set it up. So again, the first fraction, we're going to keep as is. We don't do anything special to, oh, that's bad. So 8/9 stays 8 over 9. We change the division to multiplication, and then we flip it, or find the reciprocal of 3 over 4. 3 over 4 is a proper fraction, so I can just go ahead and flip it. It's 4 over 3. I look for the answer that would match it. And so, I don't know about you, but when I have a multiple choice test, quiz, homework, whatever, I like to cover up my answer choices first, solve it, and then find out which one matches up. That way, I don't rush, I don't make any simple mistakes. And if I don't see my answer choices over there that match up, I know I did something wrong, I go back and read the question again. Looking at this, we kept it, kept the first fraction, changed the division to multiplication, then flipped it or found the reciprocal, so B was our answer. All right, now on to 6.3b, determine with and without computation whether a quantity is increased or decreased by multiplying by a fraction, including values greater than or less than 1. So, which statement about 3 multiplied by 2/3 must be true? So, let's just go ahead and start off with easy. What is 3 times 1? Well, 3 times 1 is 3. And 3 times 2, what would 3 times 2 be? That's right, 6. So why am I bringing this up? Well, if I'm multiplying the identity property of multiplication, if I multiply by 1, the number stays the same. Plug in 3, multiply by 1, I still get 3. Any other number that you're usually used to dealing with, if I multiply 3 times 2, my product is going to be greater than my original number. That's the way multiplication usually works. You multiply by a number, then the product gets bigger. But what happens when I multiply by a fraction? Let's do an easy one. What's 4 times 1/2? So I have 1/2, which is a fraction. 4 is not, so I can turn any whole number into a fraction, but putting 1 underneath it. Because what's 4 divided by 1? 4. Value is still equivalent. And so again, from the previous problems we talked about, when you're multiplying, multiply numerator by numerator. 4 times 1 is 4. 1 times 2 is 2. And then simplify, and you get 2. So I started off with 4. I multiplied it by a proper fraction, and my product was less than my original number, which was 4. Now this holds true for any fraction. Any number less than 1, and we're not dealing with negative numbers, but any number less than 1, if I multiply it 3 times, again, any number less than 1, my product is going to be less than 3. So let's look at our answer choices. So if it's less than 3, it can't be A, because my product is not going to be in between 3 and 4. Now, what about D? The product is greater than 4. It's not going to get bigger. Now, notice when I multiply the 4 times 1/2, I got 2. If I'm multiplying a whole number by a fraction, so let's look at B. Do that in a different color. 4 times 1/2 equal 2. So B says the product is less than 2/3. When I multiplied 4 times 1/2, did I get a number? Was my answer, was my product less than the fraction I multiplied it? No, 2 obviously is still greater than 1/2. What if I changed it? What if I multiplied 4 times 1/8? A much smaller fraction. Let's see what we get. 4 times 1/8 is 4 over 8, which is 1/2. Now I started off with 4, I multiplied by a fraction, and I got 1/2. But 1/2 is still greater than 1/8. So it can't be b, because if I multiply a whole number by a fraction, my product will not be less than the fraction I'm multiplying by. So it can't be b. And without computing, the product must be between 2/3 and 3. I know we're not supposed to compute, but let's do it because it's just fun. Because it's never hurtful or bad to check your answer. So let's just check 2/3 times 3. I'm going to make it a fraction by putting 1 underneath it. Now there's two ways I could solve this problem. 2 times 3 is 6. 3 times 1 is 3. And simplify, I'm going to get 2. Another way, if you know how to cross cancel, is there's no point in multiplying by 3 and then dividing by 3 because I'm going to get back to the same number. Cross those out, and that becomes a 1. That becomes a 1. 2 times 1 is 2. 1 times 1 is 1. 2 over 1. Simplified is 2. So the answer is C, because my product, which was 2, is actually in between 2/3 and 3. All right, for our last problem, this is 6.3b. Again, same teak. In the expression shown, p represents a rational number. Rational number is any number that can be written in the form of a over b. So what value of p makes the expression equal to a number less than p? So I need a number. If I plug in a number to p, and again, if I have a number next to a letter, that means to multiply. Okay? So know that. A number next to a letter means to multiply. So, what can I plug in that will give me a number less than 4p? So whatever I plug in here, if I plug in, I'm just going to put x. If I plug in a number for p, it's actually going to be less than 4. Okay? So, now on this problem, we talked about if I multiply a number greater than 1, when I started off with 3 times 1, and then I went to 3 times 2, 3 times 2 was 6. My product was greater than my original number. So I need to find a number that is less than 1. Why? Because if I multiply anything by 4, less than 1, I'm going to end up with something less than 4. So, now they're all in fractions, so this shouldn't be hard to do. Let's look at A. 9/8. If I multiply 4 times 9/8, who cares what the product is going to be? But ask yourself, is my product going to be greater than 1 or less, or greater than 4 or less than 4? Obviously, it's going to be greater than 4 because 9/8 is an improper fraction, which means my product is going to be greater than 4. I can show that really fast. 4 times 9/8 is 36 over 8. 8 will go into 36 4 times. 6 is a remainder. 4 is a remainder. 4 over 8 is 1/2. And so multiply those, you get 4.5. And 4.5 is obviously greater than 4, but I want something less than 4. 9 over 17. This one is also greater than 1. It is an improper fraction, and we just showed that multiplying a whole number by an improper fraction, my product's going to get greater, so it can't be B. I believe it's C, so I'm going to put a check mark here, but let's see. D, could it be D? If I multiply a number times 16 over 16. But the thing is, what's 16 divided by 16? Well, it's 1. In the identity property of multiplication, what if I multiply 4 times 1, what am I going to get? Well, 4. But I want a number that's going to equal less than 4, so it definitely can't be D. So that must mean the answer is C. Why is the answer C? Because if I multiply 4 times a number that is less than 1, I'm going to get an answer less than 4. 8 will go into 28 3 times with 4 as a remainder over 8. 4 over 8 simplified is 1/2. and 3.5 is less than 4, so we did it correctly. So, going back, I did not actually include 6.3c. We'll hit on that later. So in this video, we went over 6.3a and 6.3b. Hopefully this has made sense. If you have any additional questions or concerns, feel free to email me at jhewlett@leisd.ws. Thanks, and have a great day.